Hi friends, we have a very interesting concept here, the performance difference between the between operator and the in operator. There's so much discussion about these two operators as to which one is faster. Is it the between operator or the in operator? And there's so much content on the internet where people try to compare between the two. If one was always faster than the other, you would never use the other one. So there are some content, some demos that show you that both are equally good and SQL Server Optimizer will automatically take care of things. You may choose either one. There's another section of people and demos that show, okay, between goes faster than the in operator. And then there's other section of the content which shows that in goes faster. So there are all sorts of content and demos and explanations about these two operators. Of course, in their own demos and the content, they're right and they try to show things and it's great and good and you should go and read that. So I thought, why not put all of this together so that you get the complete picture, the 360-degree angle of what really happens inside the SQL Server engine. And this is where I do this video. And this video is just the starter, just the beginner, because when you take these operators and start doing comparisons, there are so many different permutations that you can bring about. And this is what I'm trying to show you as to when you're testing things, you got to look at all possible angles. All right, let's get right away into the demo and see this for ourselves. We're going to use AdventureWorks 2016 for the demo. Let's pull this results pane a little down. We have a table here, person.person. You have seen me earlier using this table quite a few times, and this table has a few attributes like first name, last name, and then there is one called email promotion. I'm calling out these attributes because these are the ones that we are going to use in the demo today. First things first, we'll make a copy of this table and we'll call this as person.contact2. Okay, let's go and do that. I don't know why am I not calling it as person2, but anyway, let's call this. Okay, so we already have this table. Let me drop this table because if I have any indexes, everything will get dropped. Okay, so we drop the table. Let's go and create the table again. So now we have this table person.contact2, a brand new table with 19,972 records. And you know that this is just created now. So it is a heap, which means there is no clustered index. Now we are going to create a clustered index on the attribute business entity ID. Let's do that. So informally speaking, this is a clustered table now. Let's go and verify that how many indexes we have on this table now. We use the system stored procedure sp_help index, and you can see that we have a clustered index and the index key is business entity ID. So the point to be noted, no non-clustered indexes just yet. Now I'm going a little back and starting things from very beginning, and then we'll come to the crux of the content in just a while. Now we have two SQL queries here. Both of these select statements are getting all the columns from this contact2 table, from the base table. So if you look at the first one, select star from this table where email promotion is between 1 and 2. So in the first select query, we use the between operator, and in the second one, we are using the in operator. So if you look at the phrase there where email promotion is in 1, 2. Now, I will right away not jump into the difference between the between operator and the in operator or how the optimizer treats them. We'll look at a few examples, then we'll talk about the technicalities here. Now, the syntax is very, very straightforward to use. So between 1 and 2, and this one is using the in operator. Okay, let's go and run both of them together. And when you run both of them together and the actual execution plan is turned on, so either click on this icon, small icon there, or press Ctrl M so that you can get the execution plan. Let's do this and see what does the optimizer really think. You're getting all the data and you have put your filter. Let's jump over to the execution plan and look at the result set there. Now for both of these execution, first things to be noted here that we are performing a clustered index scan. not we, not you and I mean the optimizer, right? The execution engine is performing a clustered index scan for both of them. And if you look at the performance comparison, let's zoom in, both of them are 50%, which means for the optimizer at this very moment, the between operator and the in operator is equivalent in terms of performance and also in terms of execution, in terms of the plan itself, the access methods that the operator is using, the cardinality estimation, the scanning, the seeking, or whatever you call it, they are identical. Both these plans are right now identical, and that's why you get 50% and 50% in terms of performance. So this is the clustered index scan, and it is well understood why this is a clustered index scan, because there are no non-clustered indexes. All right, now let's scroll down, and now we are going to create a non-clustered index. So I choose two attributes here, email promotion. And you know why am I using email promotion? Because email promotion is one of the columns that is being used in the where clause. I am also creating, I'm also using another attribute here, another index key, which is first name. And this will be evident to you in a while. Why are we using first name here? So I put first name as well. So we are creating a composite index, email promotion, comma, first name. And both of these attributes are index keys. I'm calling this out specifically because we are not using the include keyword. So in this demo, there's no concept of include here. Both of them are index keys, and this is the order of columns, email promotion, comma, first name. It's important for me to call this out, and you should also remember that the order of columns do matter in an index formation. So email promotion, comma, first name is not the same as first name, comma, email promotion. Anyway, I shouldn't be talking too much about that right now because it is not relevant. You know, even though first name is an index key here right now, don't worry too much about that, because the query, both our select statements are not dealing with first name at all. And email promotion is the first column which solves the purpose. So all that we're trying to do is we want to seek, right? And that is the reason why we put email promotion as the first attribute. So after email promotion, whether you have first name or last name or middle name or any other set of attributes really do not matter right now, given the context of these two queries. Okay, so let's go and create this index. All right, index created. Now we will run the same queries again, which is get all the columns. So we have star, star. This is same as what we did earlier. Let's go and execute. Now, some of you might be thinking while you're watching this, okay, now the index is going to be used. Let's check that out. Jump over to the execution plan, and our indexes are still not being used by the optimizer. The optimizer still decides to do a clustered index scan, both for the between operator and the in operator, and the performance is 50% again for both of them. So this is the same execution plan that we got earlier. So a simple answer to why the index was not used, because we are asking SQL Server to give us all the columns from the table. Select star is the culprit here because you're asking for all the columns. The index only has first name and email promotion. Okay, I should say the index only has email promotion and first name, only two attributes. It also has business entity ID because every non-clustered index includes the clustering key by default. So it has 3 columns, but you know this table has like more than 10-15 columns, so you want all of it. If you ask SQL Server and tell SQL Server, hey, you know, why didn't you seek on the index and then do a lookup on the base table to fetch other columns? The optimizer will simply tell you, hey, that would have been more expensive, which is looking up on the index and to fetch the additional columns, doing a lookup from the base table. The seeking plus lookup would have been more expensive. Because you're asking for all the columns, the easiest thing to do is just go and scan the data and fetch out everything that you need and render it to you. Okay, so this is simply a cost-based decision. All right. So that is why SQL Server decides to use the same clustered index scan operator. Now things will change a bit and things will start spicing a bit. we are only asking for email promotion attribute, right? Star gets replaced by email promotion, both in the first query, which uses the between operator, and the second operator in. Again, so let's go and execute both of them now. And this doesn't really even need a guess because you know what's going to happen. So let's jump over to the execution plan now. And if you see, SQL Server, as expected, will now seek on the index that you created. So this is seeking on email fname. This is seeking on same index, of course, IDX email fname, and performance wise, both of them are 50%. All good until this point, and everything is working as expected. Okay, we're already like 10 minutes into this demo and we haven't still come to the crux. We are coming. We're just building up our knowledge. We're just building up from step 1 to step 2 to step 3. Okay. Now, friends, all good as expected. Index is being used. We have started using the index. This is what we wanted. Now comes the tricky part, right? So now we are asking SQL Server to give us email promotion and first name. Okay, so we want these two attributes, and we that's the only change we have done to both the queries. So as always, the first query is using the between operator and the second query is using the in operator. We just add first name to the equation. You know that first name is already part of the index, right? The one that we have created. So is anything really going to change? Let's go and execute and jump over to the execution plan. And if you look at the execution plan, it is identical again. Nothing changes. You still have index seek on the index that you created in both cases, and you have 50% performance. Equally good, identical plan. Both of them have the same performance from an optimizer's perspective. You know, when we look at all these plan comparisons, we are only looking at the execution plan, which is the estimations by the optimizer. But just to call this out, because you shouldn't feel that's the de facto way of doing things. When you are running queries and looking at the execution plan, whether you look at queries in an isolated fashion or whether you compare them with other queries or other rewritten versions, always look at actual numbers, which is the read numbers, the CPU time, elapsed time, etc., which is the runtime statistics. That is important. In this particular case, it is not important, so I'm not jumping over to that. I'm only sticking to how the optimizer works. But in real world, you will always look at runtime statistics whenever you're baselining, benchmarking, or comparing performances. So that's just to call out. All right. So we were here, we were looking into email promotion and first name. We get the same plan, all good. Now let's add first name in your query. Now things will start really interesting, and things will spice up a bit. Look at the query. The query has changed a bit. Earlier, we only had email promotion in our where clause. Now we also add first name in our where clause. So we say first name like Lowland, percentage, okay, whatever. That's one of the names there. And we do exactly the same in the second one. So we have introduced another attribute here in our filter, in our predicate, which is first name. And of course, the criteria is also identical. Email promotion, however, remains same. So we have email promotion between 1 and 2, and here email promotion in 1 and 2. This is what has been since the very beginning. Now, when you go and execute this, you will start noticing differences now, okay? And this is where the behavior of the optimizer will be questioned as to what's really happening inside the engine. Now, before I run this query, again, just a reminder, first name is part of the index. And now you understand why I actually created the index with first name also as the second column. So you already have an index, right? Which is on email promotion, comma, first name. And the order of columns is email promotion, comma, first name. Let's go and execute this now. Jump over to the execution plan. Now let's scroll down a bit here. Okay. The first thing that you are going to notice here, and to many of you as a surprise, let's pull this up a bit, is first things first, both of these plans look identical. Okay, let me zoom out a bit there. Okay, so you can see both of them together. Yeah, both of these plans look identical, right? So you have an index seek going on email fname, and then SQL Server decides to do a key lookup. Fair enough. And then you have an index seek happening again here with the in operator, and then SQL Server deciding to do a key lookup. Plan looks identical, but what about performance? Look at this. So SQL Server decides to do 84% here and 16% here. So performance wise, SQL Server thinks that or estimates that this is more expensive, much more, I mean, maybe like 5 to 6 times more expensive than this one. So this is the between operator, and this one is the in operator. When you look at examples like these, you tend to believe that, okay, the in operator is working faster and the between operator is slower. But just hold on. Now you are seeing we are coming to the crux of the demo here, and the behavior of the optimizer, how the optimizer is treating your query with the between operator and the query with the in operator. So what you have seen, between operator is turning out to be more expensive, and the in operator is turning out to be less expensive. But what is baffling you and me here is the plan looks identical. That is baffling us. Okay, so first let me just zoom out here and just tell you one more thing, that the query was changed a little in sense that we started using star again, right? I didn't call out that earlier because I wanted to bring that key lookup into picture, into the overall equation. That doesn't really change too many things, but just calling this out, that to make the plan a little more realistic and to do that performance comparison. So both of the queries are still identical in sense that the first one is also asking for all the columns, and the second one is also asking for all the columns. Later, when you have this script and you're practicing this yourself, which you can very easily, try to just put email promotion and first name there. Okay, so we have the select star, and we worked on both of these columns. Coming back to our original discussion, the plan looked identical. We had key lookup in both of them. That is because of the star. So that clears out that first question. The second is, some of you might be thinking about the order of columns. You might be, hey Amit, the index is created with email promotion comma first name, but your query has first name and then email promotion. Does it really make a difference? The answer to that is no. It does not make a difference as to what is the order of columns in your query. So whether you write first name and then email promotion, or email promotion and then first name, does not matter. The order of columns in your query does not matter, but the order of columns in your indexes do matter. That's very, very critical. So when you create an index, specifically multi-column indexes, data is sorted in that particular fashion, right? So you have data sorted by column first, comma column second, comma third column, so on and so forth. So of course, column 1, comma column 2 is not the same as column 2, comma column 1. I mean, the so-called structure is same, but of course the data, the way data is sorted and stored is different. And if that is different, seeking and traversing the index becomes different. Well, that being said, remember, we are still dealing with only one index. We just have one index with email promotion, comma first name. And now we are looking at this query, and we saw this behavior where we get the identical plan and we see that there is a performance difference. So I answered two things, just a quick summary. I answered two things, that because of star, key lookup came into the picture, which is fair enough. That's not really much to discuss about. And I answered the second question about the order of columns, right? So order of columns in the query does not matter. So we are still, with these two being answered, we still have that confusion and that understanding, okay, why is between becoming expensive here and why is an in operator less expensive? The third question that might come to your mind and may be coming to your mind while you're watching this is the order of column in the index itself. So if you have this query which is given this option of index email promotion comma first name, SQL Server chooses that index because that's the only index available. You are thinking now, hey Amit, why not change the order of columns in the index? In that case, will between be more expensive, or will in continue to be less expensive, or will it go reverse? In will become more expensive, between will become less expensive. Can that happen? Etc. So let's do one thing. Let's change the index now. Okay, so what we are going to do is we will drop this index, which is, I've named the index that way, email underscore f name. Let's drop this. Okay, and let's create the other index that you might be wanting to do, which is first name comma email promotion. Let's do that. Now we have changed the order of columns, and I will maintain my statement, which is the order of column in the index does matter, but the order of columns in the query do not. Okay, time to check again. The same workload, same query we are running again. Select star. We have first name, then email promotion using the between operator, and the second one using first name and email promotion with the in operator. Now the index has changed. Let's go and execute this. Now let's jump over to the execution plan. Let's see what happens. Where you go, and now you will find something very interesting. Let's zoom out a bit there. Okay, so what SQL Server has done here again, again you see an identical plan. You again see index seek with key lookup, here index seek with key lookup, but now performance wise both of them are 50%. So this looks identical, this looks equivalent. So you had the same plan earlier as well. Now, whether that was the same plan as this one, we'll talk about that a little later, because there's some suspense to that. Of course, there has to be, because even though the plans looked same, there was a cost difference, 84 and 16%. But in this case, both of them are 50%. So I'm assuming that, of course, these both plans look identical, and their performance, their cost is also 15% relative to the batch is same. So they are identical. Okay, so you change the order of columns in the index. You got this. So as per this example now, where you have changed the order of column in the index and you gave that index to the optimizer, between and the in operator are performing equally well. So between is not winning over in, and in is not winning over between. But in the earlier example, when you had a different index, in was winning over between, 16% versus 84%. Okay. Wow, this is going super suspenseful, okay? Thriller. Okay, let's do one thing now. Let's create that first index again, and let's give both the indexes to the optimizer, okay? This is going to be super interesting. So create index IDX email f name, where you put email promotion and first name. This was the first index that we had created. Now, when you create this index, okay, when you create this index, now the optimizer has both the indexes, the index with email and first name, and the index with first name and email. Now we are checking these two queries once again. What's your guess? What's your guess? Which index will the optimizer use? Will the optimizer use this one with email promotion and first name, or will the optimizer use first name and email promotion, the other one? Let's take 5 seconds, think about this. 5, 4, 3, 2, 1. Think. Which one will the optimizer use? Okay, you've made your decision. Let's go and run both the queries, the between and the in. Let's go and execute. Jump over to the execution plan. And what do you see? Let's zoom out a bit. Okay, just take a look at both the execution plans. Look at everything, look at the finer details. Is everything identical or is there a difference? If you look at both the execution plans, both these plans are looking identical. Yeah, we are doing an index seek, we are doing an index seek, we have a key lookup, we have a key lookup, all good. And the performance is 50% for both of them. But friends, look at this. The first one, the first query with between operator decides to use the index with first name and email promotion, and the one with the in operator decides to use the index with email promotion and first name. So between operator and the in operator, both of them decide to choose a different index. This is what the optimizer is doing now. Given the choice of the index, the optimizer has taken the right index for the right operator. And that way, performance-wise, both of them are performing equally well. The plan looks identical, but in general, the plan is really not identical because both of them are using different index. The puzzle is still not answered. What is happening behind the scene? Why is the optimizer choosing one index with the between operator and the other index with the in operator? What are the rules the optimizer is playing by? Time for solution. Yes, time for solution. To get to the solution and watch the full video, I invite you to become a member of this channel. If you're watching this on YouTube, be aware that we have a members only section where you can access all our paid webinars, a lot of advanced tutorials on SQL Server, a lot of advanced demos, including the solution to this problem and the full version of this video. If you're watching this on SQLmaestros.com, there's another option. SQL Maestros also has membership options, and you can choose the premium membership to again get access to all the paid webinars and the advanced content. The full version of this video and the solution is also available there. So we have two platforms at your disposal. The choice is yours. You can watch and get all this advanced content on either platforms. I know you might be hating me when I am doing this, but I do produce a lot of free content for the SQL Server community, and I know you're kind enough to allow me sometimes to do this, where it's always good to have a lot of free audience, but we always love to have some premium members. So either on YouTube members only section or SQLmaestros.com premium membership. Watch a lot of advanced content out there, including the full version of this video with the solution. Happy SQL! If you like the content, give it a thumbs up, subscribe to the channel, and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there, video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.